Hello everyone and welcome. Today we're diving into the world of the domain name system or DNS. Think of DNS as the Internet's directory service. It's a fundamental component that allows us to use friendly domain names, instead of complicated IP addresses, to access websites and online services. So what exactly is DNS? The domain name system is a distributed, hierarchical naming system for computers, services, or really any resource connected to the Internet. Its main job is to translate human-readable domain names, like example.com, into Internet Protocol addresses, often called IP addresses, that computers use to identify each other. In simpler terms, DNS is like a phone book for the Internet. It lets us use easy-to-remember names instead of numerical addresses. The DNS is organized in a hierarchical structure, much like an upside-down tree. At the very top, we have the root domain represented by a single dot. Below the root are the top-level domains or TLDs, such as .com, .org, and .net. Next come the second-level domains like example.com or google.com. And finally, we can have subdomains such as mail.example.com. This hierarchical structure allows for efficient and scalable management of domain names across the entire Internet. Let us take a closer look at how domain names are structured. Starting from the left, we have the subdomain like mail. Then we have the second-level domain such as example. Next is the top-level domain like com. And finally, there is the root domain. It is important to note that domain names are read from right to left in terms of DNS hierarchy. Here are some common top-level domains. Com, which is used for commercial entities, org for organizations, net for network-related entities, edu for educational institutions, and gov for government entities. Also, there are country code top-level domains, such as US for the United States, UK for the United Kingdom, JP for Japan, DA for Germany, and CE for Canada. Now let's walk through the DNS resolution process. When you type a domain name into your browser, the browser first asks a DNS resolver, which is often maintained by your Internet Service Provider or ISP, to look up the corresponding IP address. The resolver then queries a series of DNS servers, starting with the root servers, to find the authoritative name server for the domain. Once the IP address is found, it is returned to your computer, allowing your browser to connect to the web server. So the process is like the client, such as the browser asks the DNS resolver and the DNS resolver asks root servers, then TLD servers, authoritative name servers, and after getting the information from one of these, it saves the information in the DNS cache memory. Finally, the IP address is provided to the client. Here are the detailed steps of the DNS resolution process. First, the browser checks its own local DNS cache to see if it already knows the IP address for the domain name. Second, if the IP address is not in the browser's cache, it checks the operating system's DNS cache. Third, if it is still not found, the query is sent to the DNS resolver, which is usually at your Internet Service Provider. Fourth, the DNS resolver checks its own cache for the requested domain. Fifth, if the resolver does not have the IP address in its cache, it starts a recursive query process to find the authoritative name server for the domain. And sixth, once the IP address is found, it is returned to the client and cached for future use. Now let us take a closer look at the recursive query process. First, the resolver asks a root server for information about the domain. Second, the root server responds with the address of the appropriate top-level domain server. Third, the resolver asks the top-level domain server about the domain. Fourth, the top-level domain server responds with the address of the authoritative name server. Fifth, the resolver asks the authoritative server for the IP address. And sixth, the authoritative server returns the IP address for the domain. DNS servers store various types of records, which provide different kinds of information about a domain. First, there is the record, which maps a domain name to an Internet Protocol version 4, or IPv4 address. Then there is the quad A record, which maps a domain name to an Internet Protocol version 6 or IPv6 address. Next is the name record or canonical name record, which maps an alias to another domain name. We also have the MX record or mail exchange record, which specifies the mail servers responsible for accepting email for the domain. Then, there is the TXT record, which stores text information and is often used for verification purposes. And finally, there is the NS record or name server record, which delegates a DNS zone to authoritative name servers. DNS caching is a critical mechanism for improving performance and reducing network traffic. It temporarily stores DNS query results at various levels, such as the browser cache, the operating system cache, the resolver cache at your internet service provider, and even at the authoritative name servers. Each DNS record has a time to live, or TTL value, which specifies how long the record can be cached before it needs to be refreshed with a new query. Common TTL values range from 300 seconds, that is 5 minutes, to 86,400 seconds, which is 24 hours. To wrap things up, let's touch on some advanced DNS concepts. There are DNS security extensions or DNSSEC, which adds digital signatures to DNS records to protect against DNS spoofing and cache poisoning attacks. There is Anycast DNS, a routing technique where multiple servers share the same IP address, improving performance and redundancy. We have DNS over HTTPS, often called DO, which encrypts DNS queries to enhance privacy and security. Also, there is DNS load balancing, which distributes traffic across multiple servers. DNS propagation is the time it takes for DNS changes to be updated across all DNS servers. And finally, there is DNS filtering, a security technique that blocks access to malicious domains. In summary, DNS is a critical infrastructure that enables the modern internet, and understanding how it works is essential for anyone working with online technologies. Thanks for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.